Hi everyone. In this lecture, we will talk about introduction to linked list, which is a very simple data structure but yet powerful. So, if I talk about what is a list is nothing but it's a you can say collection of items. Maybe you have a list of fruits. Okay, um, it in some sense it looks like a array only. Okay, but in C++ or in when we talk about linked list, internally how this data is being stored. Maybe we have apple, we have guava, or we have some other items. Okay, internally it may be stored in a different kind of a manner. Okay, so what happens exactly is array is a continuous memory, but linked list is not a continuous memory. Maybe you have one item in this part of the memory, another item in this part of the memory. Let's say this is one, this is two, another item in this part of a memory, and another item in this part of the memory, and these items are connected to something we call as pointers. Okay, basically what happens is the first node stores the address of the second node. Let's say this address is a, so this a will be stored here. Let's say this address is b, so this b will be stored here. Okay, let's say this address is c, so this c will be stored here, and you don't have anything here, so this will be 0 or null. Okay, and one more thing you need to note, you need to note to know the address of the starting node. Okay, maybe this address is x, so we will say okay, we have a address x, and we also call this address as head of the linked list. So this is how it is stored. Now you may ask, what is the difference? The difference is in linked list you can allocate nodes dynamically. Okay, so that means whenever you need a new node to store data, you can do dynamic allocation. And also, if large piece of linear memory is not available, a linked list can be used because you may have small chunks in the memory which can be used. Okay, now you may ask, okay, where do we actually use a linked list? So one example I can think of is in graph problems. Okay, we will see in graphs, when we are going to implement graphs, we will make frequent use of list STL. Okay, so this list is nothing but it's a doubly linked list. And also, if I talk about something more real, so let's say you see maybe posts on Facebook, so you see multiple posts. Okay, so this first post, second post, third post, so I can say this news feed is a list of items. Okay, so maybe they are using actually linked list, or they're using something which looks like a linked list, I don't know, but yeah. So in many real life applications you will note that the data needs to be stored in the form of a list of items, and that's why you should know about lists. Okay, let's move on to some basic operations that you can do in on a linked list. So insertion, you can insert a new node. Maybe you want to insert a node at head, so this is how you do it. Maybe you want to insert something at the end. But another advantage that this linked list offers is you can also insert in the middle. Maybe you want to insert 2.5, and what you will do, you will say okay, let me create a node. Okay, and from here I go to the position where I want to put this node. So I want to put this after 2, and in the address of 2 I look at, okay, what is there? It is storing the address of 3. So what I can do, I can say okay, let me do one thing, put the address of 3 here, so this connection gets formed, and let me put the address of this node here, so this connection gets formed. Okay, so this is how you can do insertion in the middle. Okay, similarly, you can do searching. For searching, you need to iterate over all the items in the linked list. Deletion is quite similar. You go to the position where you want to delete. Suppose I want to delete this node. Now what I go, I go to 2, and I say okay, I want to delete the next node. So get the address of the next node from here, and maybe you say delete address. Okay, whatever is the address you get, you use the delete operator, and this node will get deleted. And also you put the address of this node here. Okay, so before deleting you should actually do this. You store this address in a temporary node, and then copy this value here also. Okay, so that is something you can easily figure out yourself. Then what you should know about linked list is how to create a linked list, how to delete a linked list, how to print a linked list. These are very simple operations, and since it is an advanced course, I will not be going through each of these implementations in this particular course. But what things you should keep in mind while solving linked list problems: implementations can be little tricky, although the logic is straightforward, but you need to be careful while handling corner cases and null pointers. Okay, so a lot of problems that people get in linked list problem is because of segmentation faults. maybe they're not copying the address properly, or maybe they're missing a case when the head is null or the tail is null, something like that. Now let us also come to the point, how do we represent a node? Okay, so what is a node? A node will have a data of type t. This t can be integer, it can be a book, it can be some object. Okay, so I say this data is of type t, and also I'm storing the address of the next node. So I call this field as next. Okay, so this whole thing forms a node of the type t. So this is how we use generic templates in C++, and I call this as node star next. Okay, a pointer to a node which is of the type node t. So this will have the data type node t star. Okay, so this data type is node t star, this data type is t. So this is how we create a node structure, and inside it I have also created a constructor function. So this initializes the data of the node. This data is of type t, and by default whenever a new node is created, I put this value as null. Null also means 0. Now how do you actually create nodes? Since we do dynamic allocation, okay, maybe you want to create a node of type int, so you will write node of type int star n equals new node, and you give the value here. This is the data. Okay, so what happens in this case is, let us try to visualize this operation. So it creates a pointer variable. Okay, so this is of the type node star, and this address is n. It is going to store the address of a new node. This node is created on a heap memory. Okay, this goes on a heap memory, and this points to this, and maybe I can say the data is 10 and the next is null. So this node star n is now the head of linked list, which contains one node, and the value of, let's say this address is abc. This is storing abc. Okay, so it's going to be a hexadecimal address 0xabc 0xabc, something of this kind. So I hope you now understand the difference between a node and a node star. Okay, node is this complete box, a node star is just the address of this particular box. So this is one concept. If you're not coming from a C++ background, that should be very useful to understand. And now we will dive deep into the linked list problems. And just for an overview, the first problem we will do is insertion in the linked list. Okay, that will give you an idea how to play with linked list and how to create it. And we will see these three functions: insert at the head, insert in the middle, and how to print a linked list. So let's see in the next lecture.